Hi, I am Beth Shapiro. I am the Chief Science Officer at Colossal Biosciences, and right now we are focused on stopping species from becoming extinct and bringing extinct species back to life. Direwolves are one of the many species of canid, that's everything from wolves and foxes and coyotes, that were alive in North America during the last ice age. The earliest fossil that is confidently identified as a direwolf is about 250,000 years old, and we know that they became extinct at the end of the last ice age, sometime around 13,000 years ago. Direwolves were big wolves. They were larger than gray wolves that we know today, more muscular, had a slightly different shaped head and jaw. And we now know, because we've been able to extract DNA from two direwolves, one that lived 72,000 years ago in Idaho, and one that lived around 13,000 years ago from present-day Ohio, that they also, at least these two individuals, had a light-colored, dense fur, like white almost fur. This is based on looking at the sequence of DNA in their genomes. When we think about de-extinction, we're actually thinking about something that we're calling functional de-extinction. Once a species is extinct, it is not possible to bring back an identical copy of that species in every way. But many times the extinction leaves a hole in an ecosystem where interactions between animals can no longer happen because those species are extinct. So when we are thinking about de-extinction, what we're thinking about is what were the key traits that defined that species, that made that species fill that hole in the ecosystem, and can we bring them back? In the case of the direwolf, we were trying to recreate a wolf that is larger and more muscular, and then also has this external trait, the external characteristic of this light-colored coat. And so these are the DNA sequences we focused on. In the end, our goal was to make as few changes as possible to the DNA code to recreate that direwolf phenotype. The impact of de-extinction or on genetically engineering species that are alive today will vary by what that species is. For the dodo, for example, there is currently no large fruit-eating bird in these habitats of Mauritius Island. That's the only place that dodos ever lived. And so by creating something that is functionally equivalent to a dodo, we can restore those interactions to the ecosystem. In Tasmania, the extinction of the thylacine left the role of the keystone carnivore, that keystone predator, vacant. And much like we saw happen to Yellowstone with the reintroduction of wolves, the reintroduction of a functional thylacine will have cascading consequences to the rest of that community. And most importantly, as we develop these tools, we will be able to apply them to species that are still alive, but in danger of becoming extinct, to help them to adapt more quickly to the rapidly changing habitats that they're in. Imagine, for example, if we could make Hawaiian honey creepers able to live despite that they get avian malaria, a disease that was introduced by people that's driving them to extinction. With collaborators in Australia, we've created cell lines of an animal called a quoll. This is a very adorable little marsupial carnivore that eats amphibians. Right now, quolls are very much in danger of becoming extinct because they eat introduced cane toads, and cane toads are toxic. And when a quoll eats a cane toad, they die. But we have made a change to their DNA code that changes one protein, modeled after a protein that evolved on the other side of the world in mammals that eat toxic amphibians, that would make these quolls able to eat the cane toads and survive. This is how we want to apply these tools of genome editing and cloning, all the tools that we would need to bring a direwolf back to life or a mammoth back to life, to help stop species that are alive today but threatened with extinction, to avoid that fate. Well, today, as I record this, Romulus and Remus are about 7 months old. They're pretty big, but they're still pretty playful. They're still in that puppy phase. They're brothers, so they spend all their time together running around on their massive environment where we're watching them every minute of every day. They can't so much as get a splinter without us noticing. And they get to play. They have exotic lives. I kind of wish I was Romulus and Remus and Khaleesi, their little sister. She is about 3 months old, and she is adorable. She's my favorite. She has much softer features, perhaps as you'd expect for a little girl, but still super floofy and very exciting. And she's still really young. So she likes when people who she knows come around, she'll run up there and try to chew on your finger a little bit. She is pretty adorable. We'll be introducing her to her brothers over the course of the next couple of months and really watching them as they grow. Ultimately, we probably will make somewhere between 6 and 8 direwolves that will be able to be part of this same pack. But they're going to live their life in this exotic reserve. It's a very large reserve that's certified by the American Humane Society, where they will have as much enrichment activities as they need, and we can study them and make sure that they're healthy and happy long term. We can measure any changes to their DNA because of the edits. We can explore and study how they interact with the environment. This is the next phase in one of these projects, where we collect the scientific information that we need to figure out whether this is an approach that we should be able to apply more broadly to the de-extinction of other species, and also to help species today to adapt to their rapidly changing habitats. When I was in high school, I knew what I wanted to be when I grew up, and it was a broadcast journalist. And I worked for a local TV station. I worked for a local radio station. I went to college to do broadcast journalism. And then after my very first year in college, I took a class. And it was a really cool class where we started off on the East Coast. I was an undergraduate at the University of Georgia. We started off on the East Coast and we drove across the country over the course of 9 weeks, up the West Coast and then back across the country, sleeping in national parks, learning about the geologic history of our country and the archaeological, anthropological history of North America. And I thought to myself on that trip, these are the stories that I want to tell. I want to talk about how this landscape has changed with the extinction of things like mammoths, and mastodons, and giant bears. How the landscape changed again when people first arrived, and then again when Europeans arrived and really changed what was happening. These are the stories that are going to help everybody out there figure out what we need to do to be able to get to a future that is both richly biodiverse and beautiful and filled with people. And I decided that I would be a science journalist. And I thought the only way to get there is to get a degree in science. So I'm still doing that part. And maybe someday I will turn around and go back to the journalism part.